right, greetings students. This is a lecture that will deal with deductive arguments and what I call the 7 keys. This is a form of deductive argument. We're going to focus mostly on what's called propositional logic. I'm going to walk you through the 7 most important arguments that you need to be able to recognize and understand why they are valid and how they might be used, and be able to spot them in the wild when you encounter them online or in news pieces when you're trying to persuade people, and also recognize when they're being manipulated and used incorrectly. So this is Deductive Logic, and I'm here in my home studio bringing this to you so that we can walk through the material. There's also material obviously in the textbook, and also I provide links to some other professors who walk through this as well. But I wanted to give it my own spin, give you a chance to sort of walk through the way it is presented on the logical lodestone, that card that I have given you in the course. This is just that same material. I'm just walking through and explaining it to you. This is also on the logic lodestone that I provided for the course. This is the chart. I call this affectionately the chart, and it basically walks you through how to think about what kind of argument you're looking at, and then how to decide if it is valid, invalid, sound or unsound, cogent, uncogent, such as that. So first of all, you have to make sure you're dealing with the statement. So we've already dealt with that. It has to be a declarative statement. So what time is it is not a statement. Shut the door is not a statement. But once you have a couple of statements, then you can have an argument. And to be an argument, it has to be a couple of statements in which the person is suggesting that the premise leads to the conclusion, that one of those statements leads to another statement. Then we have to decide which kind of argument are they making, deductive or inductive. So for the sake of this video, we're going to be assuming that they are making a deductive argument. And the most important thing to keep in mind for a deductive argument is the person making the argument is stating that if their premises are true, then the conclusion is irrefutable. The conclusion must be true if their premises are true. So if their form of their argument is a definite, absolute conclusion, then they're making a deductive argument. If it has the kind of probably or most likely, then that's inductive. But this video, we're going to be dealing with the issue of deductive arguments. So I want us to zoom in a little bit here on the deductive argument. And the first thing we have to decide is the argument valid or invalid? I frequently discuss arguments in the form of an architectural drawing and then construction. So you've got to have good plans and good materials. If you have a bad design, the best materials in the world will not make it a good building. And if you have a great design but faulty materials, then you also have got a building that's not worth having. And so in this case, the plan that we want to look at is the argument valid? Is the form correct? That's why we call this formal logic. So is the form correct? Is it valid or invalid? Once we determine that it's valid, we move on to the question of the premises. But if the argument is invalid, we don't even care about the premises because the argument is dead on arrival. So we're going to be looking at 7 arguments so that you can identify these 7 valid arguments. I started out by saying that you had 7 keys. Actually, there's a few extras tossed in here for good measure. The most common deductive argument that you encounter on a daily basis is mathematics. So mathematics is a deductive argument. That is, if I add or multiply or work the square root correctly, if I do the process correctly, then the answer has to be correct. And that's why, as learning math, that you can tell, no, the answer's wrong because you did something wrong. The premises were true. You somehow reached a wrong conclusion. So mathematics is the strongest form of deductive argument. The next one I think is underrated, and I think this is a very powerful deductive argument, which is definition. We can say something is sort of true by definition. In other words, if I told you that I have a sibling who is a bachelor, by definition, you know that my sibling is male and not married. That's in the definition of the word bachelor. So using deductive argument and deductive logic, I can infer that if I have a sibling who is a bachelor, it is a male, and that male is unmarried. So that's the power of definition, and this is why very famous quote often attributed to Voltaire is that, basically saying, if you want to talk to me, then we need to define your terms. So we need to make sure we even know what we're talking about. Remember, back to our beginning, arguments have to have TLC. And the first thing is clarity. We have to make sure we understand what we were talking about. So then we have the other 7 of these keys. I'm going to walk through these one by one and give you examples of them. And so here they are sort of laid out all together. As again, you have this in your logical lodestone. In logic, we like to use variables, P's and Q's, and S's and various things, mainly just to save time from having to keep writing the whole thing out, because arguments aren't necessarily just short little sentences. Arguments can be paragraphs long. And so you want to say, the argument in paragraph 2, 3, and 4 leads to the conclusion in 5 and 6. And you don't have to write all that out. So we use variables to just represent them. By the way, the phrase mind your P's and Q's means sort of behave and do what you're supposed to do, is a reference to logic. That is, you're supposed to keep your P's and your Q's in the right place and follow the right order. So this is what they look like, spelled out in what we sometimes call logic book form, so that they're using variables. You can use any variable you want, and frequently when you're trying to work out a logical argument from the wild, it helps it if you use a variable that is maybe the most significant word in the argument, so that you can remember that if you're talking about, all robins can fly, you might want to use R, because that's your robin premise. So that's sort of what we're doing. So here we go. All right, first up we have disjunctive syllogisms. I don't know why I put them in the order that I did. Disjunctive syllogism, I think, is the most natural. I could even ask a very small child to use this form of logic, and they just don't know it has a name. So if I say to them, I have a box, and in the box is either a Reese's peanut butter cup or a peppermint, and I tell them, well, it's not a peppermint, therefore they know it's a Reese's cup. That's a disjunctive syllogism. I give you a choice. It's this or that, and then I tell you one of them is not the case. Okay, so let's imagine that I'm dropping my son off to school, and when I drop him off, I say to him, your mom or I will pick you up after school. Mom or dad will pick you up after school. Then later, I text him and say, well, it's not going to be mom. Therefore, he knows it's going to be dad, or I could be lying. Okay, this only works. These syllogisms work if the premises are true. Remember, deductive arguments, assuming that the premises are true, the conclusion is absolute. So if the statement, mom or dad will pick you up, it will not be mom, therefore it will be dad. By the way, in a disjunctive syllogism, you always put the term that you're going to negate on the left, S or P, not S, therefore P. I don't know why, that's just a rule. It just keeps everything clean so that you know where to find things. It's sort of like lining up your numerals when you're doing a math problem. You want to keep everything in the right order and lined up so you know what's what. So there you go. That's a disjunctive syllogism. Now, this also is a disjunctive syllogism. Dr. Shell is a millionaire or a billionaire? Well, he is not a millionaire, therefore he must be a billionaire. Now, this is valid but not sound. Okay, validity is the form. This is a valid disjunctive syllogism. P or S, not P, therefore S. So, again, we'd write this out more like M or B, not M, therefore B. But because there's a false premise in here, is that Dr. Shell is neither one of those. So, since the premises are false, the conclusion is not known, cannot be proved. And that's a very important point. An invalid argument might lead to a correct conclusion, but only by accident. That is, the logic didn't necessarily get you there. You could have just gotten lucky. Remember, we talked about, there's a chart where I talk about sort of the forms of logic. And you might get lucky, but we don't want luck. We want absolute certainty. All right, next up we're going to talk about categorical logic. This has been around since the days of Aristotle, who first developed this way of sort of explaining our reasoning. If you think about it, when I can't open your brain and look in there and see how did you reach the conclusions that you did. So formal logic is a way of sort of trying to write it out and express what you're thinking so that it can be analyzed. And so that's what Aristotle tried to do with these categorical statements. And so it has to have 3 lines, and we'll talk much more about this later. We'll do an entire lecture on categorical logics, but just the brief summary. So what you're basically saying is there's a category, and there's certain things that are inside that category, and then certain other things inside that category, and then we can make distinctions or statements about the relationship. This is, by the way, illustrated by Venn diagrams. Venn was a logician as well, and he designed Venn diagrams to help illustrate Aristotle's logic. So, as you may not have known, that arguments have names. We're going to learn the names of several arguments. Within categorical logic, they all have these letter designations and numbers. So this is an AAA1 argument. Arguments have mood and figure. You didn't know that at all, did you? And we're going to talk a lot about that later. So don't worry about that. Don't stress about that. But this AAA1 designates the 3 different statements. There are 3 statements. They're all A statements, and they are in the figure of number 1. And it goes like this. All people are mortal. Socrates is a person. Therefore, Socrates is mortal. So I've drawn these little canisters. Again, you could use Venn diagrams as well. But the biggest category is mortal. That's the dark blue one. Inside the category of mortals are persons. That's the lighter blue. There are other things that are mortal. Cats, dogs, sparrows, bedbugs. Things that are mortal but not persons. So, in the huge category of mortal, I've identified a subcategory, persons. And inside the category of persons, I identify one particular person named Socrates. So, Socrates is a person, and if Socrates was a person, then he was also mortal. So, using categorical logic, you're able to really make sure that you're comparing apples to apples and not apples to oranges, because oranges would be outside the category unless you're talking about fruit, in which case that's a whole different kettle of fish, to mix metaphors terribly. Now, again, we have to be careful because we need to distinguish validity from being sound. That is, if the premises are incorrect, then we are uncertain, and it's an unsound argument. It might be valid. So this is a valid argument, right? Let's see. Doctors can write prescriptions. Dr. Shell is a doctor. Therefore, Dr. Shell can write prescriptions. Now, that is false. Now, the form is right. Doctors can write prescriptions. Michael Troy-Shell is a doctor. Therefore, Michael Troy-Shell can write prescriptions. That is the correct form. It is a valid form, but it is unsound because of the first premise, that all doctors can write prescriptions. Medical doctors. But you can be a doctor, in my case, of philosophy, and you cannot write a prescription. So there's also some issue here of clarity. That is, the word doctor covers a very broad terms. And so there's a, remember, TLC, it has to be true, logical, and clear. So this forms an unclear statement, which leads to an unsound argument. All right, so our next argument, our next key is a famous one, has a name, modus ponens, which means basically the argument that affirms. And so we're going to have to look at the way the argument is structured. It basically says that if P, then Q. And then you are going to affirm the first part, the P part, and that gives you, therefore, the second part. It's probably easier to see it here. Let me move it to that next frame. So in logic, we use this little horseshoe to show a relationship of then, if, then, a conditional. And the part in front we call the antecedent, and the part in the back we call the consequent. If P, then Q. So if something happens that fulfills P, then Q will happen. If it rains, then I will get wet. So if something fulfills the beginning part, then the second part will follow. So this is important to understand in a conditional, because both modus ponens and modus tollens are going to deal with what happens when you deny or affirm one of those two pieces. All right, so I don't know why, but this is just my favorite example of the old modus ponens argument. If it snows, the mail will be late. It did snow, therefore the mail will be late. Now again, when we're making these sort of logical statements, you just take it at face value and assume in common language this is what we're saying. So this person is saying that if it snows, the mail is going to be late. It did snow, then therefore the mail will be late. So what we basically say here is that the second statement affirms the antecedent. It affirms the P. So if P, then Q. The P in this case is snow. It did snow. I'm affirming the antecedent. And then the result, therefore, is the consequent. Okay, so there you go. That's the modus ponens argument. And of course, by now you have figured out the pattern, that the modus ponens argument is always valid, but not always sound. So if it's constructed right, if it's in the form of if P, then Q, and then you affirm P, and then you should get the Q, but that's not always the case if it's valid, but it's not sound. Okay, so if Dr. Shell drives a Mercedes, he must be rich. Dr. Shell does drive a Mercedes, therefore Dr. Shell is rich. The problem here is that there's an assumption that the first line, that everybody that drives a Mercedes must be rich. And as you can see in this picture, Dr. Shell did drive for a brief time an 80s Mercedes. It was actually a borrowed 80s Mercedes because my car was in the shop. That's how poor I was. So I was not rich driving a Mercedes. So the first premise is false, that all people who drive Mercedes are rich. It is a proper modus ponens argument, but one of the premises is false. Therefore, you cannot conclude the conclusion. You don't get the conclusion. So modus tollens is essentially the reverse, that instead of affirming the antecedent, you deny the consequent. You deny the second half of the if-then. So, if it snows, the mail will be late. The mail is not late. Therefore, it did not snow. So you see what happened here is because I denied the consequent, you get the negative of the antecedent. If it snows, the mail will be late. The mail was not late. Therefore, it did not snow. Now, what happens with modus tollens most often is that people try to reverse it. And rather than deny the consequence, they try to deny the antecedent. And that is an invalid form of argument. And people do this a lot. People make this mistake all the time. If it snows, the mail will be late. The mail is late. Therefore, it must have snowed. So what you're supposed to do in a modus tollens is that you deny the consequent. In this case, what they tried to do is affirm the consequence. But you can only affirm the antecedent. I always remember it this way. I always say American Airlines only flies to D.C. American Airlines only flies to D.C. You can affirm the antecedent. You can deny the consequence. But you can't do the reverse. You cannot deny the antecedent. You cannot affirm the consequent. Those are logically they're meaningless. And so they don't lead to any conclusion that is valid. So you may have already anticipated this response, but if it snows, the mail will be late. But there are many reasons that the mail might be late. And that does not necessarily mean that it snowed. So when you affirm the consequent, you are not guaranteed to have a logical conclusion. So you can affirm the antecedent, you can deny the consequence. Modus tollens denies the consequent. So next up is the hypothetical syllogism. And hypothetical syllogism is sort of like a set of stairs or a links in a chain, so that one phrase leads to the other, and it's a link of if-then. We use this all the time. If I get off work in time, we will go to the movies. If we go to the movies, then we will see the latest blockbuster. So they are contingent. That's why they're called hypothetical, that if something happens, it will lead to the next thing. So in logic book form, they take this style, if S then P, if P then Q, therefore if S then Q. If you study, you'll get an A. If you get an A, your mom will be proud. Therefore, if you study, your mom will be proud. So that A leads to B, B leads to C, and A leads to C. So now this does not always hold if the premises are false. Again, we have that same problem. So here we are again, a perfectly valid hypothetical. If it rains, Dr. Shell will be late. If Dr. Shell is late, we all get A's. Therefore, if it rains, we all get A's. Now, that is perfectly valid, but it's unsound. Because the second premise, if Dr. Shell is late, we all get A's, is not true in any universe. So just because it follows the correct form does not necessarily mean that the conclusion is correct. The premises also have to be correct. So these final two are a little esoteric, and for our general use, that doesn't necessarily seem like it would be that helpful. When you get into advanced logic problems, then you would use these keys or little tricks. A simplification is sort of, I guess I always seem like it's Captain Obvious. Okay, so if I tell you that I have a peanut butter and jelly sandwich, then you can also assume that I have jelly. So if I have two and they're linked by an and, peanut butter and jelly, then you know by inference that I have jelly. You also know by inference that I have peanut butter. So you can take those pieces apart if you only need one part of them, as long as they're linked by an and, not an or. If I say peanut butter or jelly, then you don't know which I have. But if I tell you I have peanut butter and jelly, you know I've got both. So that is called simplification, because I can break it apart and claim each individual part as also true. Now, this next one seems really odd. It's called addition, and it means that given a statement, if you add an or, then you can add anything you want, and the statement remains true. Again, this is kind of bizarre, but think of it this way. If I told you that Dr. Shell is a professor, okay, if that's true, then the statement Dr. Shell is a professor or he is a firefighter is also true, right? Because if P is true, then P or anything else, King of the universe, right, is also true, because we've already established that P is the case. Now, this again is rather esoteric. You have to watch, because a lot of times this is used sort of in advertising, right? If you're told that you could be a winner, the implied premise is, or you might not be a winner, right? But they want to get you in the store. They want you to get to sign up because you might be a winner, and the other side of the or is or not. And so this is a logical tool that you need to know that is out there, but is kind of obscure in its use until you get into kind of advanced propositional logic. So now it's judgment time. Here's a chance for you to see how well you did and if you understand these various arguments. So let me give you an example. Suppose I said to you, if you study, you will get an A. But then you tell me, I got an A. Therefore, you must have studied. Is that right? Pause this, listen to it again, try to write it down, and then we'll discuss it. Old RBG up there on the bench is a little intimidating, so let's just take it down a notch. So what I posed to you was, if I study, then I will get an A. And you said to me you did get an A, and then you asserted that therefore you must have studied. Now, it looks like you're trying to make a modus tollem argument, but you're affirming the consequent. And that begs the question, are there ways to get an A without studying? What I said was, if you study, you will get an A. But are there ways to get an A without studying? Sure. You could get really lucky on your the test. You could pay off the instructor. You could happen to just know this material really, really well and didn't need to study. So deductive logic is really powerful, but it's very precise. It's more like a laser and not like a shotgun. So when I say, if you study, you will get an A, I'm making you a promise. If that premise is true, I'm saying if you study, you will get an A. But I'm not saying anything about what will happen if you don't study. And I'm also not saying that there aren't other ways to get an A. But I'm making this assertion. If you study, you will get an A. And you did study. Therefore you will get an A. So being able to identify the kind of argument that's being made, deciding is it valid, then you go to the question of the truth of the premises. And we'll be talking about criteria of truth and how do you know if something that somebody is asserting is a valid argument. We can get that part. Then the question is, how do we decide if it is true? What does it mean for something to be true?